Kia ora, Year 11, 12 and 13. Here's question 1E from last year's integration paper. Now this one is another area under a curve question, and it's a little bit trickier than the DE question that I just did. The integration is easy, but you have to see something to make this question work out. So let's just go through it and see what we might do with it. So the diagram below shows us the graph of a function, and this is the function. So the function is not that hard, right? It's an exponential, and we're told that the point KK lies on the curve. So this is the point we've got here. Now from that we know straight away that the X value here is K, and we can see that this value here is 0. So the shaded region in the diagram is bounded by the curve, the X-axis, and the line X equals K. In other words, a vertical line there. So far so good. Show that the shaded region has an area of a half K. So it's just like kind of achieved low merit questions by the looks of it. And it is until we get quite far through it. And then we just need a little flash of insight to make it all work out. So to find the area under the curve, we're going to call that A. And that comes from this integral, the integral from K to 0 of my function. My function is a half times e to the x minus 1 dx. So let's expand out the brackets. There's no need to do anything too complicated. A half e to the x minus a half dx. Right, let's integrate that and substitute in what we've got. So this will just stay as 1/2 e to the x minus a half x, evaluated at the limits. So this is equal to 1/2 e to the k minus 1/2 k minus 1/2 e to the 0 minus 1/2 times 0. And that equals 1/2 e to the k minus a half k minus a half. So the problem is that we haven't got what we wanted to get. We wanted to show that the shaded area had a region of a half k. But our shaded region has got an area of negative a half k, but this extra stuff here. So what we have to do is to use one more fact in the question to somehow link up these two bits and get the answer that we want. And here's the missing thing that we haven't used. This point here, Q, has got values KK. But we know that if Q is on the curve, that it must fit this equation. So that means that I can write the following thing. And I'm just going to write it right up here. You can do it neatly in your book. K is equal to a half times e to the k minus 1, which is equal to a half e to the k minus 1/2. So now let's get back down to the end of my integration and see whether that helps us. All right, so from above, what have we got? Well, we've got that k is equal to 1/2 e to the k minus 1/2. But that's sitting right here. So that means that the area is equal to, let's reorder it, 1/2 e to the k minus a half minus a half k. Now we're done, because this is equal to k minus a half k gives me 1/2 k as required. So there you go. I think that's a really cool excellence question. I really like it because it makes you have to be very confident of your integration skills. Right, let's just go back over the structure of the question. We were looking for the area under a curve, and we know that to do that we need to have some limits of integration, right? And this limit here is given to us, it's k, and this limit here is 0. So the integration part of the problem is nothing hard. It's seeing this link here between these two things here. Thanks for watching. I will do question 3E in a couple of minutes' time once this is uploaded.